Section 1.2 is called rate of change. So something mathematicians are really interested in is how things are changing. So for example, if we look at how population changes over time, is it constant? Is it increasing? Is it decreasing? How does the price that farmers charge for their coffee beans change the price that you're going to pay for your morning cup of coffee? Or how does changing the flap on a wing of an airplane change the angle of descent or how fast that plane is traveling? So we're going to start by looking at something called the average rate of change. So the average rate of change of y with respect to x over an interval from a to b is the change in the dependent variable, which is y, divided by the change in the independent variable, which is x. So that's kind of a big mouthful. So let's break that down by looking at this picture over here. So if I put an A and a B on this graph, oops. So here is my point for A, and here's my point for B. The average rate of change is represented by this line here. So it isn't about looking at a single moment in time, but an average showing the difference in y from the starting point to the ending point. So it could do a lot of different things in between, but really if we're looking at the average rate of change, all we care about is that start and stop. So think about the stock market. So here is some Amazon stock. If you bought stock up here and you sold, say here, you can connect those. So that would represent that average rate of change. And so here you're going to lose some money. The price was higher when you bought it and it was lower when you sold it. Okay, it went much lower than that. So if you'd sold down here, you would have lost more money. Suppose instead you bought it here and you sold it up here somewhere. Then that average rate of change is this line here. And while there was a whole lot of times where it was less than what you originally paid for it, eventually over time, in this case, the price went up. And so you made a profit by selling your stock up here. So that profit is just this difference here in this line. Okay. So let's go back and look at that formula. We're looking at the change in the dependent variable, which is y, divided by the change in the independent variable, which is x. So that change we represent with this Greek letter delta. So that triangle is the Greek letter delta, and it represents change. And that's true whether you're in math or physics. That's kind of a commonly used symbol. And you might know this formula better as y2 minus y1 over x2 minus x1, okay, which looks like that slope formula that you learned back in high school. So let's give this a try with a word problem. So number one, a store sells fresh pineapples. Based on data collected from selling pineapples when the price is $2, approximately 80 pineapples are sold. If we raise the price to $5, we're going to sell about 50 pineapples. Find the rate of change in demand from the price of $2 to the price of $5, and then interpret that in context of the problem. So let's start by finding that average rate of change. And so we know it's the change in the independent and the dependent variables. So one way of working on that is to think about how you would graph this. So if I made a tiny sketch of this graph, I would put the price on this horizontal or x-axis because that's the thing I can control. I can set the price at $2. I can set that price at $5. And then what I would be interested in is measuring how many pineapples are sold at that price. So we'd be looking at that 80 pineapples here. And if we increase the price, we sold more like 50 pineapples. So we're really looking at this as being our average rate of change. And so the price will be our independent variable, which will be in the denominator. And then the number of pineapples sold is going to be our dependent variable, and that'll be in the numerator. So if I make the price to be $2, I'll sell 80 pineapples. And if I make the price to be $5, we're predicting that we're going to sell about 50 pineapples. So when I do that math, I get 30 in the numerator divided by a -3. And so that gives me -10 as my average rate of change. And then to interpret that in context, each time I increase the price by $1, we will sell 10 less pineapples. So we could write that as 10 over 1 if that maybe makes it a little easier to see. And so as we go up by $1 in price, the number of pineapples we sell should be decreasing by 10. That's kind of our expectation there. All right, so that should give you a good first example of average rate of change in a word problem and how to interpret that.